Hello everybody, welcome to today's class. Here we have a very nice Olympiad math challenge before us here. In solving this question, you just have to be careful so that be able to get all the four pairs of solution to this. I've seen these questions on the internet and most persons solve it, they got only two pairs. But yeah, I'm going to give you four pairs of solution to this math challenge here. So the question is x to the power of 2 minus y to the power of 2 equal to 19. How do we get the pairs of x and y that satisfy this equation? So we take our solution right here. Okay. Now, seeing this question, let's put it down here. We have here x to the power of 2 minus our y to the power of 2 equal to 19. Now, if you look at the left-hand side of this equation, you discover or you can spot out a special algebraic identity. It says that if you have your a to the power of 2 minus b to the power of 2, this is equal to your a minus, of, let's take the plus sign first, plus b close bracket a minus b close bracket. All right, so if we consider this special algebraic identity, the left-hand side of our equation is of this kind. So we want to express it in this format. So doing that, this now implies that our x plus our y close bracket x and minus y, this is equal to 19. All right. So what we do, because we're having a product here, so we have to factor this 19. And if we find the factors of 19, it's just plus minus 1 and plus minus 19. So our equation could be written as bracket x plus our y close bracket, then bracket x minus our y close bracket. This is equal to our plus minus 1, then we have plus minus 19. Easy. Okay, so what do we do next in this expression? Now, in some of the content I've seen, yes, it is true. They say that because our x plus our y is greater than our x minus y, so we are going to ignore some factors here or some cases here, but no. We are going to consider all the cases, and at the end, we substitute the values of our x and y into the original equation, and we will discover that they will all satisfy the original equation, which is this. So let's take our first case, because here we have four cases here. We're going to consider all the four cases. So let's take our case one. So we have case one. What is our case one? We are going to take our x plus y equal to positive 19 and x minus y equal to positive 1. So we have this to be our x plus y is equal to 19. Then we have our x minus y equal to positive 1. Now, as you can see, this is a quadratic equation. So let me solve by adding the two equations together. And why are we adding the two equations together? We could as well subtract the two equations, but here we are adding because here we are having a plus and a minus sign. If it were to be minus minus, then we subtract. If it were to be plus plus, we also subtract. But now we are having plus minus, so we add. So here we put our addition sign. So if we add this and this will leave the system, we are left with this, which is 2x is equal to 20. We're looking for x. And so we divide both sides of the equation by 2. Then we divide this by 2 also. This leaves the system. Here we have 1 and here we have 10. So we end up having x is equal to 10. So we've gotten the first value for our x already. From equation 1, which is this, let's substitute the value x equals to 10 into that equation. So we have here x plus our y equal to 19. So if we put in x in place of, 10 in place of x, so we're going to have here 10 plus our y equal to 19. So we have here y equal to 19 minus 10. So our y will now be equal to 9. So this is the first value for our y. So we've gotten the first pair of values that will satisfy the original equation. We have x equals to 10 and y equal to 9. So let's consider case 2. Case 2. So in our case 2, we're going to consider our x plus y to be minus 1. So we have a x plus y, let it be equal to minus 1, and our x minus y is equal to minus 19. Yes, yeah, minus 19. Again, this is a quadratic equation, so we are adding again. So if we add up, well, this gives us this, leave the system again. So we have 2x equal to minus 20. Of course, we divide by 2. Here we divide by 2. So this leaves this one, this will have 10. So we have x here will now be equal to our minus 10. So we'll solve for another value of x, which is what? Minus 10, negative 10 this time around. Again, we consider equation 2 from the second case scenario. So let's rule off here and see what this gives us in turn. All right. So from my equation 1 here, we're having x plus y equal to minus 1. So let's consider that. So we have here from our x then plus 1 is equal to minus 1. Then our x will solve to be what? Minus 10 here. So this is going to give us here minus 10 plus our y equal to minus 1. So we now have this to be our y equal to minus 1 plus 10. So if we go ahead to carry out this simple arithmetic, it's going to give us plus 9. So this is the second pair of value that will satisfy our original equation. So we've gotten two pairs now. So let's take or consider case 3, which most mathematicians on the internet have not considered. So here we have here case 3. So what is our case 3? Case 3, we're going to consider our x plus y is equal to 1 and our x minus y is equal to 19. Okay, again, we add up. So if we add up, this is going to give us here, this leave the system. So here we have 2x is equal to 20. So we divide by 2 again, divide by 2 again, cancel, cancel, cancel 10 here. So we have our x is equal to positive 10. Again, remember, we'll solve for x from case 1 to be positive 10 already. Look at it here. But in our y from case 1, we have y to be positive 9. Let's see our y in case 3 if it's going to give us positive 9 also. So from the first equation, let's put this value into that. So we have here from equation 1 in case 3, so we're going to have this to be our x plus y equal to 1. So we have our 10 plus y is equal to 1. We have y is equal to 1 minus 10. Yeah, minus 10, please. Okay, so what is our y here now? Y is equal to minus 9. Now see the difference between the pairs of solution for case 1 and case 3. They are different. Okay, y is negative. Meanwhile, y in case 1 is positive. Okay, so let's consider the last one, which is case 4. We have here case 4. This is our case 4. All right, so in our case 4, what are we going to consider this time around? It is easy. We're going to consider our x plus y, let it be equal to minus 19, and our x minus y be equal to negative 1. Again, we are adding. Okay, so if we add this together, then this is going to give us something unique, right? Okay, so this will leave also. So we now have 2x is equal to our minus 20. Again, divide by 2, divide by 2, cancel, 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 cancel. So here we have 10. So we have our x now be equal to minus 10. Have we solved for any of the pairs where we have x is equal to minus 10? Yes, we solve for such. In our case 2, we have our x equal to minus 10. But the y value for our case 2 is positive 9. So let's solve for our y in case 4. It is going to give us positive 9. So if we substitute this into this, automatically it is going to give us minus 10 there plus our y equal to our minus 19. Right? Good. So from here, what we do is to send this to this side. So we're going to have our y now be equal to, we have minus 19, then plus 10. So minus 19 plus 10 will give us what? Minus 9. So we now have here, therefore y is equal to minus 9. So you now see a special pair again. From here, you discover that we've not gotten any pair of solutions whereby x is negative and y is negative. So you discover that all four cases, in all the four cases, then the pairs are different. So we have four pairs of solutions to this challenge here. So let's go ahead and bring out all the four pairs of solutions to this challenge. So we have here our x, comma, y will now be equal to, so we have this equal to, first one, we have our x to be what? Solve our x to be 10, which is 10 here, and our y is what? 9. So we have here 10, comma, 9. Then the second pair for case 2, which is this, we have our x to be minus 10 and our y to be plus 9. So we have here bracket minus 10, there, comma, positive 9. Then we take our roots to the third case, which is this. We have our x to be 10 and our y to be minus 9. So we have our x to be 10 and our y minus 9, right? Then, and the fourth case, which is x to be minus 10 and y to be minus 9. So we have this to be our minus 10, then we have our y to be minus 9. Okay, so these are the four pairs of solutions that actually satisfy the original equation. And again, let's do a simple check to this challenge here. So we have here, check. The original equation is x to the power of 2 minus y to the power of 2 equal to 19. So let's quickly check some of the roots if they actually satisfy the original equation. We're going to check the first and the last one. So let's take this first one here now, which is x 10 and y 9. So we're going to put this to be our 10 to the power of 2 minus 9 to the power of 2. This is equal to 19. Then what is 10 to the power of 2? This will give us 100 minus 9 to the power of 2 will give us 81 equal to 19. So if we subtract here, we're going to have here 1 from 0 cannot. Borrow 1 from this side to this side to give us 10. Borrow 1 from here, gives us 10, and here we are left with 9. So we have here 1 from 10, that gives us 9. So we have here to be 9, then write it where? Then here we said we left with 9. So 8 from 9 gives us what? 19. This is equal to 19. So this shows that the first pair we should solve for here satisfy the original equation. Again, let's go straight to the last one, which is minus 10 minus 9. So into our original equation, again, we have x to the power of 2 minus y to the power of 2 equal to 19, right? So this is going to give us here our minus 10 all to the power of 2 minus the bracket minus 9 all to the power of 2 equal to 19. Easy. So minus 10 to the power of 2 will give us positive 100. There is a case scenario I have analyzed in one of my solutions that if you have minus 10 all to the power of 2 and minus 10 or in bracket to the power of 2, these are two different expressions. The power here is not affecting this minus here, but here the power here is affecting this minus here. In other words, this could be written as minus 1 times positive 10 all to the power of 2. Meanwhile, this is written as minus 1 all to the power of 2 times 10 all to the power of 2. So these two expressions are different. So look at what we have in here now. And so minus 10 to the power of 2, that will give us 100 minus, then minus 9 to the power of 2 will give us 81, which is equal to 19. Again, if we subtract this from there like we did in the previous one, this will give us 19 equal to 19. All right, so this brings us to the end this math challenge. So again, this satisfy the original equation. So if we do that for the second pair and the third pair, we will discover that they will all satisfy the original equation. So with this, we come to the end of this wonderful math challenge. If you learned something from this video tutorial, give the video a thumbs up. And again, if you have any question with regards to the steps I have applied in solving this wonderful math, then drop it in the comment section. We are there to reply to your comments. This is Math Prowess, and we all here will love you dearly because you are the reason for the existence of this channel. Bye.